The world is changing at a very fast pace, and so should we. Science and technology is progressing beyond our imagination. New technologies enable us to enter a different reality. Welcome to Tage Teaches, and this is a platform to learn together and grow together.
Hello guys, welcome back with Tage Teaches, and today I have a really good video planned for you guys. Today we'll be learning about the scientific method and identifying parts of an experiment. We're not going to be doing an experiment or anything, but I'll be telling you guys what an experiment consists of and what the scientific method is. So before we start, I would like to share you guys a basic definition of what science is. So, simply put, science is our attempt to understand and explain the natural world, whether it be in the form of solid, liquid, gas, or plasma, whether it be as small as looking at quantum science, whereas it's a very big topic, but if you look at the quantum technology and quantum itself, it's very tiny. And whether it be big as looking at the universe and looking at the many planets of our solar system and many more that have yet to be discovered. So, what is the scientific method? So the scientific method is a step-by-step way that scientists use to answer a question. And it goes as is. First, they ask a question itself. Then they research on that. Then they research on a topic. They then form a hypothesis. They would then go ahead and test that hypothesis. They would gather data. They would analyze that data. They would draw a conclusion, and they would communicate those results. So, you always would start with a problem / a question. So the problem identifies what you want to find out. That problem could be as simple as finding out your type of food that you eat, or it could be a very big problem as well, like the COVID. When we were hit by COVID, that was a big problem, and the solution was to find a vaccine for it. So when we go to create a statement or a problem, creating a statement that defines a problem, you want to make sure that it's very narrowed and specific. It shouldn't be vast, including many other topics. It should be pinpointed to one or two things that is so being very specific. And also thing that you must look at is it must be testable. The only reason we were able to find out the COVID-19 vaccine, as first it was a virus, and we needed to find a vaccine. So it's just one thing, find a vaccine for it. And the problem that you state, it must be in the form of a question. For example, how does methane affect greenhouse gases? Or what is the effect of methane on our environment? And so on and so forth. Next, you must research. So, on the topic that you are doing, you must write down all the information that you already know. Then you must research the topic by using books and the internet, but you need to make sure that they're a reliable source. If you use a non-reliable source, you would be filled with false information, which then would lead to massive failure in your experiment. Next, you must ask experts on the subject that you're researching. First of all, this would help you get a better understanding of the things that you're confused by, as you may be able to ask questions to the expert on that. And second, you would get even more knowledge and even an easier put out knowledge on the table than you may get from the book or from the internet. So that's why you should ask experts. Next, you guys might be wondering, what is a hypothesis? So it is an explanation that is based on prior scientific research or observation that can be tested. Hypothesis is also called an educated guess. And it usually begins with, I believe that, so on and so forth. You wouldn't say that, I know that. If you know that, then it's not a hypothesis. A hypothesis, like it said before, it's an explanation that is based on the prior scientific research. And we need to make sure that hypothesis is tested so we can prove that it's true or it's false. So how do you test a hypothesis? First, you would experiment it. You would develop a test to support or not support your hypotheses. Or if you're looking at a different hypothesis, you must perform a test to see if it supports or it doesn't support the hypotheses. Second, it's not just one test. You must run multiple tests for your hypotheses to perfect it and also to make sure you didn't do it wrong. Next comes independent variable. You must have only one independent variable, the fact that it's being tested, the factor that it's being tested. And next, you must have experimental and control. You must have two steps. Experimental, which gets the independent variable, and control, that does not get the independent variable. So, what is a controlled experiment? It's an experiment that tests only using one factor at a time by using a comparison of a control group and an experimental group. So to put it in simple words, again, it's an experiment that would test the hypotheses using only one factor at a time. A hypothesis includes multiple things, and you won't be able to experiment it all at the same time. That's why you would be experimenting it using only one factor at a time, and by using a comparison of a control group that controls it and an experimental group that experiments it. What is a control group? The control group is used for comparison. It does not get the independent variable. So it's a group that is used for comparison and it does not get an independent variable. What's an experimental group? It's a group that gets the independent variable to see how it affects or changes something. Or it doesn't. It's up to what if you guys are trying to change something. So, what is a variable? A variable is something that can change either naturally or on purpose. Now you guys may be wondering, what is an independent variable? An independent variable is the factor that the scientists have changed on purpose in order to test the hypotheses. It is the cause. What this is saying is that scientists have changed something in that hypothesis to test it. And also, independent variable is the result of what the scientists changed. It is the effect of what happened in the experiment. This happens naturally, and no one makes it happen. The scientists do not have control over this variable. So what this says is that in the hypotheses, as they go to experiment it, they don't change anything. And this occurs, and the result of what the scientists change, it's the effect of what happened in the experiment. So this happens naturally, whereas in the first instance, that happens on purpose. What are constants? Everything that the scientists keep the same in both a control group and in an experimental group. That is what a constant is. Next, we're going to look at is how can you gather data? First, we need to make observations. Any use of the senses to gather information. Next, you must make qualitative observations. Anything that you see, smell, touch, taste, or hear. For example, it's blue, it's bitter, it's fizzing sound. It has a fizzing sound. It's bubbly, and etc. And if you use chemicals, I would recommend you not to taste it. Next, you must make quantitative observations. Any observation that can be measured, it must include a number. For example, it's 5 centimeters long, or it's 6 centimeters long, or it weighs 20 kilos or 30 kilos, and etc. So what do you do with your observation? You record them. Usually the data is recorded in a chart or a table. So what do you do with your data? You analyze it and look for patterns. When you analyze your data, it helps you create better graphs, whether it be line graph, bar graph, or a pie chart in this case as well, and complete all the mathematical calculations. So, how do you write a conclusion? This will help you a lot, as in higher grades you would need to write conclusions for 99% almost of your experiments, and that was for me. So you must follow the 5 steps. First, you must state whether your hypothesis is supported by your data or not. If the answer is yes, that's great. Second, you must restate your original hypotheses. This would help the teacher know, or the teacher or the scientist that you were providing this conclusion to. It would help them to see the hypotheses, and if they want to try it themselves as well. Next, you must use exact data to support what you have just written. Don't change something. Don't be lazy to change. Don't put every single number, because every single decimal that there is in the mathematical area, it matters. In the science, everything matters. The atomic number, everything. Don't go lazy on this. 4, you must apply an error analysis. Think about what you found out in your research, and you should consider any improvements to your procedure. And next, you must offer explanations for why you think the result of your experiment were what they were. Ask me a question. What do you want next? So, can you guys identify the parts of an experiment? So, this is the thing. 6 bean plants are to be tested to see what happens if they're placed in the dark. They all have the same type of container, the same amount of soil, and the same amount of water. 3 plants will be placed in a sunlit window, and 3 plants will be placed in a dark closet for 2 weeks. So what is the question? What is the independent variable? What is the dependent variable? Which is the control group and which is the experimental group? That's it. To answer those questions, I'll be providing my email at the bottom. And if you guys would like any better understanding of that, please tell me on that and comment your answers as well. Thank you so much. See ya. Bye.